that's great. But then maybe we don't request every single, sometimes some of the shells have like 72 different planes in them. Maybe we need 6, so we're looking at that. But yeah, thank you.
Other data set? Other talks? And we'll move into the discussion. Thanks, Eric.
Okay. So now we go into the discussion about observations. This is Sue Wei and I talked earlier this week. I think I probably have to hold this down for the entire time. I might take a microphone. On, Tom. We went through a couple of different things, and this is not inclusive, but it is just an idea about what is currently available real-time data. What are the sort of things that are observational, that might be observationally relevant, and we are ready for feedback on this. So currently available are real-time data. C2 is real-time. Ground-based GNSS receivers for slant TEC. And all of this is clearly focused on thermosphere, ionosphere sort of things. So things that are sun-focused are kind of removed from this.
So I kind of put this together. So I want to make sure we have a proper discussion when we talk about data, because there's a real-time capability, data with real-time capability. Their data doesn't have real-time capability, right? So for the operational centric agency like us or Navy or Space Force in the future, we will be looking to the data that is currently available and sustain that capability and look out for other data. And then Irfan is here if you have any comments on those things. So what I see is what we are using right now is Cosmic 2, and we are using right now is whatever GNSS receivers that we can get our hands. And Inoson data, I mean, we used to kind of support that global database, and now it's not available for people. But I mean, within the government agencies, we're trying to purchase data with some solution. So it's not public available, but we have a handle on it right now. So the plan is we're going to purchase some of the data from one vendor. And then there are also radar data. And I think Air Force is going to talk about more of the radar data tomorrow and how that might be able to help their data simulation for whatever they need in the future. In thermosphere, we saw, right? I mean, unless we get GDC, unless we get more missions going to space to do a better measurements, that's kind of where we are. And maybe perhaps I think working with Cosmic Office, we're trying to derive neutral density as well. That might be viable operational data set we can use. And there are a lot of other middle and lower atmosphere observations that, will be useful, and probably more data in lower atmosphere. Actually, where's Fabrizio? Do you guys know how many data are there in real time for the, I saw him walk around. So I'm just wondering how much data, when we talk about time data, we talk about those data in mid-latitude, how much real time? It's all research. Yeah. Do we have extra?
Okay, I think I'm going to start walking around.
Yeah. So for that 60 to 125, the data that's available is really SSMI SUAS, and that's radiance temperatures. The SABRE does not come in half fast enough. MLS, there is near real time. Okay. And I'm sort of on watch so that if SSMIS falls out of the sky, then I jump up and I turn on all the little flags so that we start trying to assimilate MLS. But the thing is that MLS is going to go away very soon. So I haven't started or even tried to do that. So and then yeah, that's basically it. You've got it.
So still very limited. So this is what, so I think our problem is a lot more simpler just because we have less data to worry about. But I think there are also some of the data set that, really for research. John got my clicker, so I can't change slide. So there are a lot of research data, and for the ionosphere thermosphere that where I'm familiar with their network of TEC that you could play with, and their latency adding to that. There's some drift you can get from, I mean, Kamarka is actually trying to put out the real-time drift data in like 24/7, but it's 1 point, right? So how do we utilize it in our model? So it's difficult. And SuperDARM has some of drift that people are widely used in the community. And they're just on Viper system that also provide you some of the drift on top of sometimes they can get some of the wind based on the ionosphere changes. And they're also, and this is what I want people to think about. I throw this in because I feel there are a lot of HF signals and we don't know how to use it, right? Like how do we use HF signals that communicate between locations with different frequencies? And I think that's a huge amount of data that we don't know how to use it because there's no environmental parameters. So I think that's the next rich data set that I've been trying to ask this community to look into it. And there are also NPR data, and I think there was a rumor say NSF is not buying those irradiant data anymore. So, but those data set will be able to provide us the drivers, right? Field line currents, and how do we use that to drive our system? And in thermosphere, actually it was really limited. I put something together, but I don't know if there are more stuff that I totally missed. But there are a lot of their missions, and yes, I didn't include the time missions in some of this work. So NASA time mission, a lot of data in there. Mangle FPI network. So I've been always, people ask me, can we use this FPI derived wind measurements from one, estimated altitude in the nighttime? So how do we use that? So I think there are something, we're just not sure how to use it because I also don't know, how accurate those data are. So we can have more discussions. And NASA icon data has the wind and their other parameters, and then gold give us temperature and orange. I mean, it's really limited, but you guys can expand that discussion. Sorry?
How delayed is the gold? Is
I
there,
don't have a good idea. Depends on the parameters,
There's
I think.
no,
I
like, it's not, yeah, it's pretty impractical to try to elevate that to a.
Paslu is online. Are you able to answer that question?
Yeah, right now it is 2 weeks latency, but it has a great
California.
potential to make it real time.
All right, say no more.
Yeah, Greg Lucas is mentioning that Space Weather Track developed a low latency product for gold. It's currently at LASP, but I don't know the status.
Yeah, so we provided it to SWIPSI, and so and this sort of leads into another question here as well, but so we were providing this sort of process data in real time, so let's say 5-minute lag or something like that, like very fast to NOAA SWIPSI, but it was sort of for the forecasters to look at, and they didn't really know how to use this. And so it wasn't used for a DA system or anything to drive models with, right? So there's sort of different use cases for these things as well, right? Is it the forecasters that are driving the request for this data, or is it the modelers in the DA system that would be doing it? And so
What data are you talking about? How come I have
gold.
gold data?
Yep.
I have no knowledge about this. So I don't know who are you passing the data to, because if it doesn't pass to my team, I don't know where does it go. So I think
Good question. I can
but
follow up
I
with you,
think
Sue.
if the Go team say they're 2 week late, how do you get real-time data?
So Fazlul, you should follow up with me because it is at LASP, the real-time data.
And what parameter are you talking
I
about?
believe it's the ODA N2.
The 2-week gold data is like very precise scientific ephemeris. I think it was a 30-minute lag we finally settled on is an estimated ephemeris and therefore not as accurate in terms of geolocation, but It's the same data.
But so that sort of brings up maybe one thing to discuss here is that the previous slide was real-time data. This is research data. There, if I think in a neutral atmosphere point of view and from a NOAA point of view, you'd go NOAA PDA and there's a whole collection of data that is sitting there and you can pick and choose what you want. But all of those data, I would say, have assimilation operators and are known. And I would say that there is not a table or a survey of what data is available, whether it's real time or not real time, and has the data ever been assimilated before in a space weather environment, whatever, and what sort of model it was put together. A matrix of that would be useful for the Joint Center folks because they want to see what all of those observations are, I would guess.
I think that's the issue with the community, right? We get data and then we have not have a good system to demonstrate the impact on our operation. I think Irfan, you guys are funding one project to kind of demonstrating GO data impact on WAM. So I think we're gonna see some activities in that work.
Meteor radar is another example of a research observation that NRL is working with Diego Sanchez from NASA to get more low latency data out of these networks. And because the data is sitting there, it's just a matter of getting these existing instruments to speed up their data processing and get it over the internet to NRL in this case to use. So that's a way to look at this. Some of these research observations is maybe it's a lot cheaper just to upgrade their data processing and transmission systems than to try and build a new real-time instrument system.
And that's kind of a space weather enterprise thing. Maybe that's not like totally relevant for this conversations because this is a Joint Center thing and there's research there, but yeah, you're right.
Yeah, and to that point, it's actually easier to get like ground-based stations to the operational feed with low latency than it is to get the satellite. That takes a big lift. One thing I would like to hear more about is you guys working the Cosmic 2 neutral atmosphere observations. What have you guys done and what is there?
Well, I mean, for Wacom X, we've assimilated, the sort of standard neutral atmosphere stuff in the lower atmosphere, same as NRL would do, Navy would do. Yeah, same that the Navy would assimilate. He means neutral atmosphere and the troposphere. There's this thermosphere neutral density. So, well, there's two. There's a standard neutral atmosphere, RO products, right? That I think you're familiar with. The Navy assimilates. Everyone else, is assimilating. And then there's work on a thermosphere neutral density similar to ARIC is deriving with SpaceX, but using Cosmic. And it's sort of different processing. It's I think generally the same method, but process different software. And there's a student in Taiwan that we've been working with on, she's trying to assimilate this data into TIE GCM and see, what the impact would be. Does that answer so there's sort of two goal things.
I was confused about the lower. I didn't know it was the lower stuff. That makes sense.
Yeah, and so then I guess I will put out an ad is that there's going to be a day and a half meeting at the beginning of October on thermospheric density products that people from the Joint Center actually might want to care about. It's going to be at the Mesa Lab, so it's not going to be really data assimilation, but it's going to be how are these products put together.
Coming back to what you said about survey, I have one question that who have the access to all those data? Are they, available publicly somewhere, or they are distributed, or some of them are, sponsors only, or where
I
we
will
can
say
get those
the
data?
community is trying to push a unified location, and I think NSF is trying to help out. So I think they're all different places right now, but there's a push to make sure the data are in one place and documented and have a good data format. But yeah, they're all scattered right now, I would say.
Least one recommendation coming from this workshop is trying to somehow have a centralized resources, at least as maybe category or whatever, to also list out the resources.
Yeah,
of the
do they
data.
do that for the NASA mission? Do they try to put things together, or I'm just wondering, because I know the ground base is a little bit scattered right now. I wonder if somebody knows that answer, like if you want to look at Go data, time data, icon data, are they all in different kind of format and locations? Do you guys know?
Archive of those data. I
Right,
don't know that it has all of them.
right.
And I imagine that CCMC has a good collection, although it's not their main primary job to distribute data, but they have a lot of data they use for verification. So I would imagine that they have some sort of connection to what the sources are.
Cool. Yeah. Nick, do you have the answer?
Madrigal was like the ground-based condensed location for
Yeah, I mean,
data.
most of ground-based you can probably access through Madrigal, but still very hard to find those data within the Madrigals itself.
That's true. yeah.
But I think the space-based are definitely not there. They're separated. Yeah.
Right, that is a good point. All of the observations, where are they at? Are they real time? Are they not real time? What are the products? What has been, is there any assimilation done with them? Has there ever been?
So I think this is a fascinating discussion. I really like where we're going here, and I'd like to provide two additional points from a data assimilation standpoint. Hopefully that helped with the discussion. The first point is when I think about data assimilation, what we want to ingest, I always think like data assimilation has infinite appetite. You want to ingest as much as you can. Question is, how much can you? And so I think it echoes the discussion about retrieved product versus raw observations and subsets of data, and I think at the end of the day it's really about identifying what are the low-hanging fruits you start from, where you start your meal, and then what are the points of diminishing return that you might get to, but you don't start with that. So really identifying your priorities, and that might be very dependent on the application. So different partners have different priorities, and that relates to the discussion about some might want to start with real-time data because that's what they need. And so having a prioritized list of what are the observations that are that folks want to work on, and looking at these different lists and seeing how much overlap, how much differences there is, I think that's going to be very valuable.
So
I have a second point, but yeah.
Oh, so I will just say that we thought about this, and there's a point of observational priorities. You can't do 50 operators at once. So which is number one, and what are the highs, what are the mediums, and what are the lows? And that should probably be aligned with what is operational and what are future missions and where are things going. And that's probably, I would guess, the right way to tackle that problem.
Right, exactly. And just to continue on this, my second point is we have a unique opportunity with JEDI that provides, if you think about observation operators, bring your observation into JEDI. It's the Unified Forward Operator is like an app store where people can bring their own stuff. So now we can really think of it as you pick your low-hanging fruits, but now we have a team of fruit pickers, and so we can actually consider this problem collectively and think about, okay, now we have these different teams working on their low-hanging fruits. Let's make sure we're coordinated as a team so that we can start picking higher than we would do on our own, so that we can leverage this other way.
So I would say I think a lot about space and time scales right now, and just the difference in the ionosphere and space and time scales. And so they're in that same matrix or whatever, an observation might be very well suited for a very small scale local or a very high fine resolution, high time resolution product, but then it might not be applicable for, say, a global model or something like that. And so how do you know, where's the sweet spot for that observation? I think, that's. Oh, go ahead, Nick, sorry.
Yeah. Go ahead, Nick.
Turn your mic on.
I was going to go back to your, question on the satellite data. And as far as I know, it's kind of all over the place. I think in theory, NASA has like a central repository, but it's often not the same versions as you might get on different websites. And, having some more organization would be helpful for DA. I know every time I pick a new, time I want to do a DA experiment, you have to go to like all these different websites and download the data, and it's just, it's not convenient. Like I assume it's the same for you guys. Yeah, it's just not, I think that's an area where maybe, data assimilation community could make impact of like trying to get some centralized sources of these data if, it complies with whatever, restrictions exist. And the other thing, just on your observation list, there are, I would say, non-NASA missions from other, ESA and other countries that are doing thermosphere, like Swarm or Grace follow-on does neutral density. So those are, other sources.
I think that's certainly be good feedback for the agencies to come up with some priority, but I think they're trying to do it, but we gotta make sure they move faster.
Hello, Cleveland. Yeah, I think this is great, and I agree with the top one. I mean, I had a meeting with Dave and Sue at the AMS, and we tried to lay out the top priorities, and that's where we came up with the list that Dave presented, the Ionasan, and that was just a good start. But on your third and fourth point, as a knob guy, that's a big one for me, is what do I verify against? And they're obviously the research data. So a priority on the research data, where we have confidence in the errors of these, are gonna raise some of the ones. I mean, if gold is 2 weeks late, but it's a very good data set, that's a great one then for us to use to help establish our errors and our uncertainties, look for correlations which came up and these type of things. So, I mean, that's when you're putting together the list, I just want to highlight that. And then also Tom's bringing up one of the features of JEDI, one of our components is the R2D2. So we put things into Yoda, and as this group, we want to come up with a consensus on, because all the data we have, this is the name, this is the unit it's in, and it's all defined. We all use the same units, the same name, and we can use long names. It's 2024. It can be a very long name. Please know HMF2, because that's what we use forever. Just say what it is in words. You don't have to use a 4-character Fortran 1980 name. So think about that, and I'll let you lead. But yeah, with the R2D data store, everything's in a globally readable NC dump, H5 dump, easy read by Python, and a lot of tools. So if we can get it in that data store, that's actually a way to facilitate sharing.
So one thing about that is, I would say that this community has not embraced NetCDF or common data formats as much as other communities. I will just, that will be a challenge, is to come up with a data.
So I'll bounce on this. So Yoda, so JEDI relies on Yoda for ingesting the observation. Yoda is the interface for observation data access. And the whole concept is to insulate the scientists from the nitty-gritty, file formats, NetCDF versus buffer versus whatever. The whole idea is, scientists, you just want to say, get my data. You don't want to know even what format you read it in. And that's what we're doing with Yoda. You can have actually backends with Yoda with multiple formats. You don't even need to know, and the bucket can change. You can add more. And so what R2D2 is actually designed to do. And so to be fair, it's not there for the space whatever, but we're putting this together for marine and terrestrial. It's actually you have an integrator where as you add more observations, new instruments, they come into that common pot. and they're readily available. And you never need to know which format, which data ingest it came from. If you're really curious, you can know all of this is traceable, but it's all available right away. And so someone else might have put it in there, or maybe you put in there for others to use. But now collectively we build these, and so the data access, we really lower the bar to, because it's a huge, time sink, and honestly not very rewarding, and also very redundant across teams. So we try to help with that.
I would say that's one of the huge draws of JEDI, that they'll be able to clear up this observations all over the place and hopefully bring them together. But to get back to Ben's points, I think the errors and uncertainties, that fourth point, I mean, obviously that's central to the DA. That's our big problem. And to get our observations in the same format and together so that we can start talking about the errors and uncertainties together and come to, really wrapping our head around that is extremely important. And so this has to come from both the community, the observation guys that are taking the observations. As you were saying, there's places in the world where there's question of the quality, and that needs to come back through the data set so that we know where these uncertainties are popping up, and so that we use our data sets the best of our ability. And also, as you were saying, that setting up quality control. I mean, the tropospheric world has armies of people that have been doing this for decades of keeping the quality up, and we're building this from the ground up now. And I think as far as like machine learning and stuff like that, I think there's areas that we can utilize some of that stuff, but it's a big problem and that we need to wrap our heads around. So.
My comment is on that same topic of like, when we're looking at these research data, providing quantified uncertainties is really not their priority a lot of times, and it's really missing, and it's kind of like, oh, it's like 15%, it's like 10%, but yeah, because I guess they don't think about like the data assimilation impacts and needs that we have. So just like another problem to kind of have to worry about.
And a component of that is, and what Tom was talking about, Yoda, and you don't really have to care how that data came. You do want to track metadata. And so while you made to just having a bunch of anonymous data going in and not having how it was obtained and stuff, tracking metadata is terrible in this field. Oh, sorry.
Well, I think Valerie has a question online. Valerie, go ahead.
Thank you, Tsui. So basically, what these bullets, what you have here on the slide, is basically a task for observing system simulation experiment for ionosphere, thermosphere, mesosphere system as a first start. Because now we have, during 2020-2022, having ICON on board, we have basically the goal years to build with observing system simulation experiment, having timed missions, winds and temperature, ICON missions, temperature, and GOLD missions, composition and temperature. So this is probably will be our starting point to get this and basically to start think about this. And if we start to build observing system simulation experiments for geophysics missions in using JEDI, so I believe this will be great community resource, and it answer on all, not all, but part of these questions. What kind of latency accuracy? What will be observational priority? Winds, temperature, composition, verification and validation. We can basically confront different data, temperature and winds from different sensors. And of course, there are uncertainties. We already have real data. So I think this will be a great opportunity to build community observing system simulation experiment using information from the existing thermosphere and ionosphere sensors.
Thanks, Valerie.
Okay, Megan. Sorry, I want to go back to what Ben and John mentioned earlier about the naming convention and the metadata. I actually have an action item. I didn't mention that, but I would like to have a small team, but talking about the naming convention and metadata, because that's our first step. We haven't come to that yet, because we have the first converter at this point for TEC coming from the Ionosound and GNSS-RO at this point. But we come to the point that, you know, what's the naming for that? And also metadata, we even haven't talked about that, but that's definitely is one of our action items. So please stay tuned because I would like to have some serious discussion before we even move forward to the data repository we are going to have. And another point is that I would like, you know, even not today, I would like to have a table that, you know, we have the priority saying, Ionosound, this is easy, vertical profiles, let's get in. That's what we did with Navi and Shui. I would like to have something like that. And also, you know, data availability, you know, where it is, for example, and who is doing the data simulation for that. And if we can come back with such a, you know, kind of like John mentioned, a survey, something like this coming from people from this group, that will help us as well. And I hope the priority also coming from the operational centers, you know, what you really want to use in short term, because that's the one will have immediate or not immediate near-term impacts, right? And there will be long-term impacts coming from more research type of observations, and which one we need to keep eyes on. Then we need to get into verification and validation of data first, because we don't even need to assimilate data. We need to validate the data first. We can use JEDI HFX only to look at data quality if we, you know, we set up the capabilities. So I would like the outcome or action item coming from this group is at least have some survey table to tell us this what is the most important.
I think.
You want us to put
that-
that table together?
And leave that, John. And maybe, Irfan, if you have some comments, my personal perspective is we are building a lot of things with currently available data, right? So I do wish those data will continue while we're exploring new data sets. So I think criteria one will be continue data like RO data, and we couldn't even figure out that at this point, where are we going with space weather RO data. So I think that's like continue those data so that our service won't be terminated. So RO data, ground-based GPS data, ground-based Ionosound data, and those are basic data. We had it already, and we have probably hundreds of sites on the ground that will help, but doesn't stop us to get more new data. But I would just say continue current data is priority number one with limited budget.
Just add that, yes, I agree with you, Sue, that we should continue, at least from NOAA's perspective. NOAA has invested resources, funds in collecting data like RO data. So we want to make sure that that data gets ingested or utilized, because when that operational data, one thing that I didn't hear in data simulation, you talked about ham operators. What's the impact? How do you assess the quality of the data and the stability of the data? Because we don't have any control on, let's say, the research or data that's provided by citizen scientists. But at least with the operational data, we know at least the quality, and we know that there is a stability in the data availability. So that is something I think that this community data simulation and the JEDI can tell us, how important that is. Having said that, yes, from our perspective, the priority should be, the data that we're collecting, we've already invested in. So we want to make a case that we should continue those observations as we then assess new observations from research missions that NASA is flying, and perhaps other agencies are flying, even our international partners are flying, and then we can assess those in a development environment and showcase or show the impact of those observations. And then we can talk about investing additional resources to bring those new observations into operation.
And can I just comment on that? So if you would think about in the future that you would have a global model running and you would have a global data assimilation running, is that you could have this kind of goes to the scorecard, but basically an analysis map, like what is the O minus B? What is the observation minus background for every observations that you have? And you're going to see which ones agree and which ones don't agree. And that will give you input on, well, are they is this one accurate or is it error? And that will tell you a lot about what the quality of the observation is or the quality of your model is. That is I know that Joint Center has this for neutral atmospheric observations, but it's like it's an O minus B map. It's like I don't know what you really would call it, but that's what I call it. And that's valuable to you.
And I just want to add that I really like the scorecard concept. Every time I see somebody show scorecard, I'm like, how come I don't have it? Problem is, what do we put on a scorecard, right? We are not looking at, yes, we can put TEC, we can put NF2, HMF2, we can put density, but what quantity there to what accuracy actually impact the customers? That is the hardest question to answer. Are we looking at 100-kilometer perturbation that impact the signals, or we put TEC, right? So I think the problem about space weather is the impact on the customer is not trivial. If you get your NF2 better in that area, what does that mean? What does that even mean for the? So I think it's very hard when we talk, right? It's like, if I lose Cosmic 2 for the troposphere region, not troposphere, like the tropical region, what does that mean for the user? What does that mean when we lose RO data there? So I think that's the hardest thing, and we all have to work together on that.
So I can talk to this somewhat in this community here, but so we're the Navy and we have different needs. And with the development of these projects, we have users, and we're having to develop those user operators so that we have an understanding of our product's uncertainties at that level of the user is looking at it. And I think and so we have to do that internally, and because we have, but we also have here like these satellite drag guys, and they want to know if it's going to fall out of the sky or whatnot. So they have an idea of changes in drag and whatnot. And then what I think what the community would need to do for something like that is to create operators of, okay, well, if I had a satellite here, how much would it drop due to these conditions? And then you develop you can develop uncertainties around what that product can have. And then you go backwards a little bit, and then you have a scorecard which is based upon that. And it's a long process. I think it's a never-ending process because the end users are always changing. But it's sort of like it's the connection between the end users and to us, where the modeling and the assimilation and trying to connect that together. So.
And I have the same struggle whenever a storm comes. So our job is to quantify the storm impact. How do I even quantify the storm impact, right? I would say the 3 satellite has impact, the 3 satellite drag, everybody drop altitude. So what exactly we're talking about? I think that we still don't have established that in our community.
So for neutral atmosphere, we have 2 types of verification. One is observational space type. One is model space. For observational space, you can do, the first one is O minus B, observation minus background. And the background can be your initial guess, but it can be forecast as well. So for example, you have analysis, you forecast 24 hours, or maybe for space weather, you're doing that long. You only need 15 minutes, but you use that OMAX F, you can verify your model. But if you use that to verify your observations, you know how far your observations are for different type. You can vary against the TEC, for example, from RO. You can also verify your ultrasound against the same model. Then you know the quantity difference between the two observation types. So this is more, when you have different observational types and you use the same model, you have relatively scale to evaluate how far your observations from the model. So that's one of the observational space we can use. And when you come to the model space, usually what we do is we have the forecast, we have analysis on the model grids, and then you have forecast. Then you can use your customized score. I know that's difficult because you have different customers, but you can have different scorecard, right? Some people more concerned about electron, some people more concerned neutral atmosphere density. You can have different scorecard for different customers. But I agree with you, but at least what we can do at this point is let's doing the observational space, because we need to build an operator first, of course, but let's look at the data quantity, even not going to data simulation yet, just look at O-B, we'll have operator. Then we probably will tell that whether this will give you impacts or not, right?
I think that that's definitely the first level is the O-B is like, that's the first thing. And then, as you say, then we get into the models, and what we have some models, but we don't have a lot of models, but however many models we can, then we can start cross comparisons with that. And then you can do those. I think the thing that Sue and I am also talking about is then you can have further derived products. So products that you take you take from the atmosphere that we're making, and there's further derived products that you're trying to calculate uncertainties from, and which are important for the end users. Like maybe if we're talking about aircraft pilots, okay, well, they're interested in how long they can be up at a certain altitude, how much radiation they can take, and you can create a derived product which is trying to get at that particular thing of you're at this altitude during this day, how much radiation are you going to get, and then what is the uncertainty of that, because that's what they're interested in as well. So I think there's ways of getting to that, but you're totally right. The first one is observations that you have that you can compare to. Second is the models, other people's models, and then the third is these other derived types. In the forecast to analysis.
Not sure why I'm taking the mic. I didn't have a question or a comment.
So,
You were handing it to me like you wanted me to say something.
But I also want to make sure that we're very clear here. Okay, so to forecast ionosphere, thermosphere, if you only have data, you can't go far because its system is driven by the external drivers, right? So SUBSEA is really looking into how it can come out with probability forecasting a lot of drivers. At the same time, we know, none of our index has any probability or any error bar also. So I think there are a lot of room to improve where we are in terms of driving the model with system. I also have people, right? They come to me and say, hey, why don't you validate your WAM forecast with the WAM reanalysis data? I say it's going to be bad because my forecast driver is so bad. So I know it's going to be bad. So that is just not the same system we're talking about. It is when we predict a storm, if your timing is wrong, then it's wrong, right? So obviously it's wrong. So I think tackling forecast, and we have to balance the amount of time we put in nowcast, because every customer come to me, they want to know what happened tomorrow.
Sue, when are you going to start running ensembles?
Which one? Well, that's the other question, right? How do you do ionosphere ensemble when I have 10 model might all look different at one location?
Right.
So I think that's a really problem, because 10 years ago, 15 years ago, yeah, when we were trying to compare 5, 6 different models, they just all look different because fundamental physics are all different. So I think there's a challenge there. Yeah.
I was just going to say, this idea of comparing against models, that is one of the issue. I think even with data assimilation models, the bit we've done of models, extending into lower thermosphere, when we compare them, they're still kind of all over the place. So that complicates the idea of like comparing against analysis fields, even if they're independent models. I'm not sure you can say that's truth to the extent you can in the lower atmosphere. And in terms of like, using forecast for verification, I think you can learn something from the very short-term forecast when you add in new observation, not a 2-day forecast where it's driven by, the sun, but if you look at, a 1-hour forecast, is that better when you start assimilating, some ionosphere data versus if you don't? Then I think, you learn something there, but if you start going out too far, then the drivers become an issue.
That's why we're also trying to educate our customers, because they all come like, I want to know 6 hours from now. So I can probably look into 1 hour, but that's about it. I think that's very important.
Yeah, and I think this, I got it. I think this is very reminiscent of what the tropospheric weather community was at in the 80s. And, no one wanted to, well, maybe even before that, no one wanted to make forecasts because it was crap. But you just kind of have to start making forecasts, even though it's crap. And hopefully as we do that, we'll get better, but we have to start with something. So,
That's exactly what I was going to bring up, Dave, is that in the terrestrial weather community, for a while now, I think they've been distinguishing, and correct me if I'm wrong, but they've been distinguishing between model validation, which is, does my model do what it's supposed to do? And typically that's a metric that you produce using past observations. And then forecast verification, does my model predict the future and how well does it do? So there's a distinction there that we really haven't made in the space weather community yet. We talk a lot about model validation. And so, for instance, WAM has been validated extensively against past events where, you've got the data, it's cleaned up. You might even tune the model to make it look really nice against this past event. But that's showing you that, some of the physics are, captured correctly, but now does it actually forecast correctly? That's a whole different ball of wax. And as you say, we're not really doing that right now in space weather.
Just to sort of push on that forward is that, like, with our current system, there's this whole concept of, how good NEMO is doing or how good our NRL SAMI 3 is doing. And when we run it retrospectively, we run it with all the data that was there during that 15-minute time period. But the reality is that when we're running it operationally, that none of that's there. It's 2 hours back. And that's what we should be looking at. That's the quality and we need to start, and it takes time, obviously, and we have to go through all these problems and try to clean them up, but there's a lot of things.
One of the first things then, it goes back, cycling back, is then you have to have a central repository for all of this data.
I mean, like, I was just going to say the same thing. I mean, even though we say we put Cosmic 2, probably use less than 10% of Cosmic 2 data in ops in reality, just current ConOps. So I think, how do we do a better job with that?
And where is the central repository for DA data in tropospheric weather forecasting? Is that NESDIS or?
Yeah, they have efforts, but S3, AWS, and some of it's there. It's a bit hard to navigate.
Right now, they're running lots of forecasting models with real-time DA. They must have some sort of,
Well, in GTS, they get it on the GTS. So that's
what's that?
Yeah. No,
This observation.
so first, yes.
Weather, we haven't done any of this before.
Mhm. But so this effort from Neutral Atmosphere, WMO, they share data globally for operational centers. That's through GTS. And for people, you know, we are having connection with the operational centers. That's a big chunk of data already. So that's, but we do have, you know, commercial data and other data places is not fully open to everybody, but one of the effort from Northern Atmosphere is we propose global license for the commercial. And that's a big effort happened for the past few years. It happened among the global different commercial companies from Europe and from US. So it takes effort to come to this point, but that's why, I mean, at least the people can access to archive at NCAR for some for a lot of open, you know, the GTS data as well, research type. So there is NOAA has the data lake efforts as well. So there are efforts.
So I think, you know, it's impossible to have a central repository that's going to do everything for everyone. And at least for the tropospheric parts, you know, every agency has their own sausage making for doing data ingest, you know, through the GTS, through all sort of, you know, channels, and you know, it's actually really complicated. From a JEDI development perspective, this is what we were referring as R2D2. So this is basically a central repository to have all the data that you need to developing JEDI capabilities and building prototypes. It has no intention of being an operational capability, so that's not redundant with what the agencies are doing. It's a lot more modest in scope, but it has actually more data types than any of the operational feeds, because, you know, it's a collective central repository for that. So that's an opportunity for this community here on the JEDI developments.
Stop. So I think the day is ended, right? And there'll be a time tomorrow morning to bring these conversations back up. And then there's sort of a general discussion like after 10 or something. What time does this start again tomorrow? 9 a.m. And then there's a sort of wrapping things up. Okay. This was a pretty good conversation here. I think that it was pretty valuable. I'm glad that people contributed. Thanks. Okay. For those who are going to dinner, I didn't realize you were going up there. That's a great place to have dinner. You have a cocktail first.
It's the reservations under either my name, Rustin, or Jackson, Leslie Jackson. So if you show up, ask for Rustin or Jackson for the table. Yeah, that's it. Thank you, everybody.